Hello guys, hope you are doing well. This video is specified for the 12th graders in English curriculum. I am Jihad Hamasaid, a chemistry teacher for 12th graders. In this video, I will be talking about one of the most struggling topics in chemistry chapter 1, which is the actual unexpected values, and most of the students in grade 12 they have problems with this topic. So today I'll be talking about this topic in detail and I will explain in detail. At the beginning, guys, we have to know that in term of having solutions in chemistry, we have two types of solutions in term of conducting electric current. One, we have the non-electrolytes, the other which is the electrolytes. So the non-electrolytes, guys, are those solutions which they do not have tendency to conduct electricity because of not having existing ions in the aqueous solutions. And examples for those types of solutions: sugar, here we have sugar and alcohol in our book. So the most commonly used examples for the non-electrolytes are sugar and alcohol. And the other type of solution is the electrolyte in terms of conducting electricity. And three groups of compounds which we deal with in 12th grade, they become electrolytes: acids, bases, including the weakest and strongest guys, and soluble salts as well. So you have to know that, guys, the expected values and actual value, what do we mean by these two terms at the beginning? The expected one, let me start from to define the expected one. The expected value is a value which we can obtain theoretically. We mean by calculating the boiling point elevation, freezing point depression, osmotic pressure, and vapor pressure. By using the mathematical equations, you'll be able to calculate the expected values of those colligative properties. So, the expected value can be obtained through the theoretical tasks. But unlike the expected values, guys, the actual values are those values of colligative properties which we obtain from the experimental data. So whenever you want to convert the expected values and obtain an actual value, you have to boil the solutions or freeze the solutions in reality, in actual, in order to get the actual pointers. So, and usually the expected value should be obtained in the laboratory through the experiments of boiling or freezing the solutions. So the difference between this value uh, for two types of solutions, only the difference is for the electrolytes. Guys, you have to know that whenever the solution is non-electrolyte, its actual value results the same as the expected. But when you have an electrolyte solution, you will get a different value of actual compared to the expected value. Let us talk about the reason behind of having differences between the actual and expected values for an electrolyte solution, but not having a difference between actual and expected value between between the expected value and actual value for a non-electrolyte solutions. So guys, let us talk about the reasons behind having the difference different between the actual and expected values for the electrolytes. The reason and the only reason behind this is having existing free ions in aqueous solution of electrolytes. And that reason is the same as the non-electrolytes. They do not have freezing the differences between the actual and expected values. So guys, from this we can understand that the main reason behind having differences between actual and expected value is the attraction force between the ions. Have a look on this container. It's a container which has an electrolyte solute. We have added Kf into the water to form a solution of which has free ions to conduct electricity. So guys, uh, from okay guys, sorry. From the figure, it's obvious that we have got the two opposite ions in the solutions. So whenever in physics or chemistry or biology you have opposite charges or opposite poles or opposite ions, there will be attraction between them in any medium. So whenever an electrolyte dissolves in aqueous solution, whether it ionizes or dissociates, it will form ions, and there will be the in reality attraction between those existing ions. So when the ions attracted to each other, what will happen to the free ions in aqueous solution? The free ions as of individual ions concentration decreases. So actually, when you want to boil a solution, there is attraction between the ions will result a value to you, but theoretically we haven't taken this attraction into the calculations. We haven't considered this attraction into the calculations. That's why you'll get two different values for the actual and expected. So simply due to of having attraction force between the opposite ion in an electrolyte solution medium, there will be a different value between the actual and expected one. You may be wondering how and the actual will be higher or lower than the expected. Let us talk about whether the actual is higher or lower than the expected. Guys, for this we have two groups of colligative properties, two groups of values. I have called them as a group 5 and the group 2. So the group 5 here, simply what we mean is those colligative properties, those values which directly proportionally which they are proportional with the molality, with the concentration, as what as the boiling point elevation delta Tb, freezing point depression delta Tf, boiling point of the solution, vapor pressure lowering, and osmotic pressure as well. So these 5, they are directly proportional with the molality. And we have to know that how, if the question asked about the values, actual values of these 5, always the actual values result is a lower value than their expected. But the group 2, which are the freezing point and vapor pressure of the solutions, These two, as you know, that they are changing inversely with the molality, with the concentration. So whenever the question asked about these two, their actual value should be higher than the expected values. So it depends on the groups, on the values that the question asked about the group 5 or the group 2, and you should follow the strategy of having the lower actual than the expected for the group 5 and higher actual than the expected for the group 2. Guys, let us talk about the relationship between the concentration with the ion effective and the charge with the ion effective. So in this part of the video I will be talking about the relationship between the concentration, what will happen to the effective concentration of ions in aqueous solution if the concentration increases. Guys, simply increasing the concentration, we mean adding more solute into the solvent. This, as you know, logically, it increases the number of the ions in aqueous solution. And as in an aqueous medium, the number of the ions increases, there will be a higher attraction between the ions. So, providing more concentration, more solute to the solvent, there will be results in the more having more attraction between the ions, the opposite ions in that solution. And having more attraction between the opposite ions reduces the free ions individually in the aqueous solution. So we represent this by ion effective, the effect of the individual ions in the aqueous medium. So the ion effective, as you can see, it's downward opposite of the molality and the attraction between the ions, which the ion effective decreases. And in chemistry, for the colligative properties, guys, as the ion effective decreases, there will be a larger distance, a longer distance between the actual and expected values. So this increase in molality results in the actual value gets farther from expected. So may provide an example to you guys and ask for the whether the actual or expected value is of which of the following is the highest, has the highest difference between actual and expected value. Let me provide example for the same electrolyte. For the same electrolyte, of suppose that the electrolyte is KCl, okay, the 1 molality, 0.5 molality, 0.3 molality, and 3 molality. So among these values, which one has the highest concentration, has the highest difference between the actual and expected value? And as you know that the 3 among all these numbers has the highest value, has the highest is the highest amount, so it becomes the solution which has the highest difference between actual and expected values. So as you increase the concentration, there will be a longer distance between actual and expected. Let us talk about the charges. There will be some time the ion, the concentration of the two solution equals. The ion factor as well equals. The charge, how the charge decide the highest actual and lowest actuals. Guys, charge simply has the same effect as the concentration. What do we mean here is having a high concentration results of having a longer distance, or the actual gets farther from the expected. The having a high charge results the same effect. So as the charge increases, the ion effective decreases. And as the ion effective decreases, it results of having a longer distance between the actual and expected. So the actual gets farther from the expected. Let me provide an example for these guys. Suppose we have KCl the same and MgSO4. So suppose the example is asking about 1 molar of KCl, 1 molar of MgSO4. Which one has the highest actual boiling point? So the 1 molar of KCl, 1 molar of MgSO4, these two, because they have the same ion factor of 2, and if you multiply the 2 by 1 molar, you'll get 2, and if you multiply the 2 by the 0.51, which is the kb, you'll get almost 1. So the expected value, the expected boiling point for these two solutions is 101 Celsius. Why? Because the delta TB is equal to 1, so the freezing boiling point of the solution will be delta TB plus the boiling point of a solvent, which is water, 100 plus 1, you'll get 101 Celsius. So guys, this will be the example. Let me show you. Hundred one. Sorry, let me. Okay. 100. Suppose this is 101 Celsius. Guys, this is the expected value. Expected value for both KCl and MgSO4. So the value is the boiling point. So the boiling point is among which group? The group of 5 or the group of 2? Of course, it's among the fifth, which they directly change with the molality. So as I told you, for these are both electrolytes, the actual value of the boiling point must be lower than the expected because of having attraction between the ions. So you have to choose for each solution value below the expected. So suppose we have these two, the first one A and the second one B. So let us decide which solution, A or B, becomes the KCl. Guys, the distance, the one with the higher charge has the longer distance between the expected and actual. So MgSO4 is positive 2 and negative 2. KCl is positive 1 and negative 1. Which one has the higher charge? Of course, MgSO4. So the MgSO4 should be the one which is farther from the expected. So B here is the much farther from the expected. So B must be the MgSO4. And the A, which is a lower charge, must be a little bit closer to the expected, and the ASO is the KCO. So which one has the highest actual boiling point? Of course, A has the highest actual boiling point, which is KCO. That's the types of questions and on the charge, and also for the uh, questions related to the molality. Let us solve a question. Where is it? Sample problem. Guys, here we have got a sample problem of ministerial question. Stated that which of the following has the highest actual boiling point? It's ministerial exam question. 0.2 molar sugar, 0.1 molar NaCl, 0.1 molar MgSO4. So guys, for these values I have provided a table. So arrange it in a form of a table in order to make it easier and in order to choose the correct answer precisely. So the sugar has concentration of 0.2, the NaCl 0.1, and MgSO4 0.1. The ion factors, effects, of course, the sugar has the factor of 1, NaCl of 2, MgSO4 of 2. So guys, here the expected value, you'll get the same expected for all three solutions. How? 1 multiplied by 0.2, you'll get 0.2 for the sugar. 2 multiplied by 0.1, you'll get 0.2. 2 multiplied by 0.1, 0.2 for the MgSO4 as well. So the expected, if the question asked about the expected value, so the D will be the correct answer, and the D will be the one which has the this all have the same boiling point, if not the actual. But the actual of them, two of them, they have different actuals than the expected, the electrolytes. So guys, here let us provide by a coordinate. We have drawn this coordinate, and of course 0.2 multiplied by 0.51, you'll get 100, 0.102, and 0.102 plus 100, you'll get 100.102. So the 100.102 is the expected value for A, B, and C. But let us talk about the actual values. As you can see, the colligative property here is the boiling point, and the boiling point is among the group 5, sorry guys. So the group 5, they have a lower actual than the expected. So here you have to know that the sugar is not electrolyte. At the beginning of the video I told you that there is no difference between actual and expected value. So the actual value of A, which is the sugar, result is the same as the expected one, 100.102. But the two other, B and C, NaCl and MgSO4, they have a lower actual value than the expected. So you can see that, guys, here the actual value of the sugar stays the same, 0.2, but the actual value of NaCl must be lower than 0.2. I mean 0. What I mean 0.2 is when you multiply 0.2 by 0.51, you'll get 0.102. That will be the number, and this one is less than 0.2, the MgSO4, because these two are both electrolytes. They have a lower actual boiling point than the expected. Have a look. The A has the same expected and actual, but B and C, uh, this below the 100.102 is the actual value of B and C. So logically, which of them has the highest actual boiling point? Of course, A has the highest actual boiling point, which is a sugar, and most of the students in that round of the in that attempt of the ministerial exam, they have chosen the MgSO4 because of having a high charge. So guys, the actual and expected values, I do prefer to follow the same strategy as I have shown in this video in order to solve the questions precisely. And I hope this video is a little bit helpful in order to understand the actual and expected value. And thank you for the attentions, and hope you all the best for the ministerial exams.